Hello, my name is Domenica Ramirez and my partner is Celine Medina. Next, we are going to explain the development of an engineering criterion problem. As an introduction for the problem that the exercise, we have that the project consists of a design of a pile foundation that will serve as a base for a five-story building. This structure will be in the city of Guayaquil and must be able to support a load of 5,000 kilonewtons. The stratigraphic of the terrain is as follows. The first stratum is composed of a clay gravel with an angle of 40, a cohesion factor of 100 kilopascals, a specific soil weight of 90.4 kilonewtons per cubic meters, and a M60 of 50 strokes per meters. The second stratum is a clay of high plasticity with a SU of 90-80 kilopascals and a Saturn soil weight of 70.2 kilonewtons per cubic meters. The last stratum is also a high plasticity clay with a SU of 180 kilopascals and a Saturn soil weight of 18.3 kilonewtons per meter. Considering the data provided by the problem, the following methods we take into consideration for shad designs as alpha methods for clays and Briar's method for sands.
So, as Dominica says, we have two methods, the Browns and the method and the alpha method. Next, please. On the first, we are going to use the Browns methods because we have the number of strokes. So, in the next diapo, we can show that yes, we have you can see the image that we have the perimeter, the L, and the FS. What happened? In this case, we don't have, the problem is that we can find the dimension of a circular and a square pile, but in this case, we don't have it. So we decide to put an incomplete. In this case, we know that the perimeter of a square tile is 4b, is 4L, but in this case, it's 4b. And the same with the circle, with the circular. The perimeter of a circle is P per D. In this case, we don't have the D. We decide to put B. And we have some values, as you can see in the photo. Next, please. What happened with the second? In the second, we have the sand and the clay. But we have the presence of the phreatic level. So we have to find the saturated gamma. The saturated gamma the is the presence of is the gamma of the sun, but we have to keep the gamma of the water, as you can see in the photo. So after with that, we can calculate the vertical stress. The vertical stress is the plus of the first, the plus to the second. But in the second, we have to we have to multiply the gamma for the alture. But in the second, the alture is considered to the middle. And after that, we have the SU is a data and the vertical stress. So we can find the C. With the C, we have a consideration that if the C is lower than 1, we can use that consideration that we have in the photo. And after that, we can make the calculate, and the shaft in the calculation section 2 is 15.96 kilonewtons. Next, please. In the next is the same with the last diapo, but in this case is in the last straight. So we can make the first plus the second part plus the third, but in the third is in the middle of the levels, but it's the same problem. Next, please. What happened? We have the square and the circle shaft. So we sum all the first, the second, and the third, and we saw that we have a 1-degree equation and a scale. So next, we are going to calculate the tip. But what happened? Next, please. The tip is in the last structure. So the last is a clay. So if it is a clay, we can use Meyerhof easily. In this case, the equation of Meyerhof 9 per SU per area is the same. We don't have the dimension of the circular on the rectangle of the square pile. We can assume as incognite, and we can do the operation, and we obtain the values that you can see in the photo. Next, please. In this case, is the shaft and the tip plus tip capacities. In this case, we obtain a second degree equation, so we decide to solve it. In the square, we had two options, the positive and the negative. It's logical that we can use the positive. So with the square, we have the 1.39 meters, and in circular, we have 3, but as the same as square, it's logical to use the positive, not the negative and 0. In this case, the circular is 1.67 meters. Next, please. As you can see, with 1.39, we had a value that is near to 5,000, that is the limit. So we can assume that what with 1.39 in a square pi, it's the maximum is the maximum length that we can use to complete the value. Next, and the same is with the circular, but in this case, the V is equal to 1.67 and it's very, very near to 5,000. So after that, next, we decide to make a comproval or verification in the Excel, as you can see. Next, please. Yes, you can see in the square in 1.39 was the limit, only that comply with the condition, and with 1.40 not comply, so you can reassess. As the same with the circular, as 1.667 complies, after that not comply, and you can reassess. Thank you.
So we can conclude that for a square section, the maximum dimension that is faced to use is 1.39 meters, while for the circular section is 1.67 meters. It is important to mention that we should not work with these limit values, since it's not safe neither for the structure nor for the first users. So, according to the engineering criterion, for us, we should look for an option that is both safe and economical. Thank you.